Hello. In this video, we're going to determine the intersection, parallel, or skewness of two parametric equations. So these can be quite weird, but they're not too bad and can be quite easy as long as we set it up accordingly. The first thing we know is we have line one, and line one has an x value, a y value, and a z value. I'm going to replace those equations that they have on top and rewrite them. Now, the important thing to know is that for line two, that this t value is not the same for line one and line two. This t value only applies for line one, as in t1, and this t value only applies for line two, as in t2. So what I do is we write out x, y, z, and we replace our t with an s, creating two systems of equations with two unknown values, -4 minus s. Okay. And now all we're going to do is set them equal and solve, kind of thing. So the first thing we're going to do is put them together now. So we know that x and x are going to be the same at an intersection point. So we can now rewrite this as 1 plus 2t, because we're going to set all of these equal. 1 plus 2t equals 9 plus s. 2 minus t equals 5 plus 3s. 4 minus 2t equals -4 minus s. So that is that first step. Oops. Next, what we have to do is start to clean up, put both variables on the left and put all the values that we have on the right and combine those like terms. So we'll do it for each equation. We are going to move, so we're going to have 2t minus s. We move the s over, move the 1 over, 8. 2t minus s equals 8. Same thing on this side. We'll start with our -t, move that s over. Now we have -3s, then move that 2 over. We see it's a 3. Same thing down here. We're going to keep our -2t, move our s over, so it's a plus s, move a 4 over, so it's a -4, and we'll get a -8. All right. Now all we have to do is just take these and we're going to eliminate to find our intersection points. What you might notice is that if you take 2t, the first one, and the third one, they're going to perfectly eliminate. And you'll see 2t minus 2t, positive 2t minus 2t is 0. -s plus s is 0. 8 minus 8 is 0. So we have 0 equals 0, which represents all real solutions. So we need to set these two or these two equal in order to solve it. So that gave us a little weird situation. Well, that's okay, because all we're going to do now is instead of using those two, I'm going to take that first equation and now use that second equation. Now, if we recall, when we're eliminating, all we need to do is match up the coefficients and have different signs. So we can see the 2t on top, and we have a -t on bottom. I need to multiply the bottom by 2. We rewrite 2t minus s is equal to 8. We have -2t minus 6s is equal to 6. We resolve. So we get this becomes 0, this becomes -7s, and this becomes 14. And we see that s is equal to -2 in this situation. Now, when we get to that point, it is very important to realize, well, wait a minute, that doesn't make any sense. S is not the same. Well, that's not what we're solving for. What we need to do now is plug s back into line 2, and we will be able to easily find our intersection point. So we're going to get x is equal to 9. Let's actually keep this in black, but off color. X is equal to 9 plus, and now we can put in our -2. and we see that x is equal to +7. Then we can see y is equal to 5 plus 3 times -2, oops, which is going to get 5 minus 6, which is -1. Then we're going to get z, and we get -4 minus, and again, replace it with a -2. Clean it up, -4 plus 2, and we see this is -2. So the solution for the intersection point should be 7. So this is going to intersect, and it should be at 7, -1, and -2. Now we do have to check this. Now plug S in to solve for t, please. Back down over here. So we had 2t minus -2 is equal to 8. 2t plus 2 is equal to 8. 2t is equal to 6. T is equal to 3. We have to plug 3 back in onto these guys to make sure we get the same exact point. We should, but this is how we double check. So we're going to get x equals 1 plus 2 times 3, 1 plus 6, that's a 7. Y equals 2 minus 3, that's a -1. Z is equal to 4 minus 2 times 3, 4 minus 6, -2. And you see, we get 7, -1, and -2 again to confirm that this is indeed our intersection point for these two parametric equations.